So I'm Jana Scheller. I'm also in the School of Biotechnology, and I am the program chair for the MSc in Biotherapeutics. And this MSc sort of sits between the other two MScs you've just heard about, the Bioprocess Engineering and then Diagnostics and Precision Medicine. So I created this MSc to have something sort of in the middle that has a little bit of the engineering world and kind of how do we create drugs or biologics, biotherapeutics, and then also the life science side, the whole kind of screening of patients, understanding how the immune system contributes to the disease, what is pathophysiology, and how can we design drugs to specifically treat the diseases we talk about. And then, so the program started last year. We had the first cohort. We had 3 full-time students and 2 part-time students. So the part-time students are still here with us. The 3 full-time students have finished. And but unfortunately, I don't know where they ended up yet in terms of employment. But the course went really well, and it was very well received by all the students. So some of the material is shared between or across the other 2 programs as well. So some of the modules, if you choose to do the MSc in Biotherapeutics, you will share with the other programs, so with the bioengineering students as well as the diagnostics and precision medicine students. And then it's also a full-time option over 1 year, or part-time up to 4 years. And again, if you are a international student, you will have to do the full-time course. But then, if you are an EU student, you can do up to 4 years modular part-time. So you can do only 1 module, for example, per year. Yeah, lovely. So if you just click one more, please. Super. Yeah, thank you very much. I've talked about biotherapeutics a lot now, but what are they? They're biopharmaceuticals. So there's pharmaceuticals, which are small molecule drugs like aspirin or whatever, and then there are biotherapeutics. So these are molecules created by organisms or cells. So this would be your monoclonal antibodies or insulin. So recombinant proteins, for example, or even viruses, these kind of things. If you don't mind going to the next slide, please. So this little cartoon here that we just quickly skipped over kind of shows you all the individual biotherapeutics that are out there. But if you look at this slide here as well, you can see some of the examples on the top left there. For example, you see antibodies. So most of the cancer treatments, for example, that are still being used are monoclonal antibodies that specifically bind to proteins on your tumor, on your cancer, to neutralize this. So either targeting them so the immune system can clear them, or binding to certain proteins to inhibit the function of those receptors, for example. And then you see viruses on the top right there. So viruses are also biotherapeutics. They're produced by cells, and we can use them either as vectors, so as molecules that deliver a drug, or deliver nucleic acid, these kind of things. So vaccination, for example, virus-based vaccinations, or using viruses for gene therapy, for example. So these are all things that we are working on and that we are delivering in this program. And then you have extracellular vesicles as well. So looking at extracellular vesicles from a diagnostic point of view, but also as a therapeutic. And then you have recombinant proteins. So one of the modules, for example, is looking at using toxins, neurotoxins, and how they can be used in the clinic to treat certain neuropathic pain and these kind of things, for example. So it's a bit of a breadth and depth to this program, changing between disciplines, but giving you a big overview of what biotherapeutics are. Martin, do you mind going to the next slide, please? And the next one, there we go. Thanks. So as I said, it's quite a broad overview, so it's quite multidisciplinary. We have industry input into the teaching, but also into the content. Then the program is obviously externally evaluated. But it gives you this nice overview of basically 4 major themes that we are working on within the school. So immunology and oncology was already mentioned there by Paul, which is sort of the foundation or the kind of the main meat of the MSc in Diagnostics and Precision Medicine. So some of the modules, as I said, are shared with this program, but we have our own specific ones where we are looking at what biotherapeutics are out there, what's the state of the art, kind of what are the new ones coming down the pipeline, and how can we identify new targets, for example. Not necessarily looking at the precision medicine angle, so individual personalized medicine, but more of a broad kind of stroke. How can we treat a specific issue within a disease? And then we also working on vascular biology and neurology. So I'm a neurobiologist. I work on epilepsy. And then we are, highlighting new treatment options and where biotherapeutics coming in there. So then we really start from, what's the disease, what's the pathology, how can we treat certain aspects, certain changes within this disease, what might be good targets for new biotherapeutics, then how do we design those biotherapeutics, how do we produce these biotherapeutics either in a lab and then scaling it up into industry, what are sort of the regulations and frameworks we have to work in, for example. So really, starting at the first little step and then blowing it up into an industry kind of setting. So also in this program, you will have a little visit to NIBRD to see kind of a large scale, more industry-like setup. There may be a GMP facility or GMP-like facility in DCU as well that we might have a little look into the setup. But yeah, you will be working closely with the lecturers here. If you go to the next slide, please. So the program itself is face-to-face, so you have to be on campus. You can't take this course remotely. So lectures and tutorials are face-to-face. Some lectures are recorded, and then lecture slides will be put up online as well on a platform called Loop, where we it's Moodle, so where we collect all this material, and then you will also gain hands-on experience. So there's one practical, for example, within this course. So over a week, you will create a CAR T cell line, so a highly specialized cellular therapy for certain types of cancer. And then you will also have the chance to do a research project at the end. As I said before, it's full-time or part-time, but you can also then leave the program either with a graduate certificate, a graduate diploma, or with the MSc if you're doing all modules and all credits. Next slide, please. Super. So this is the breakdown, semester 1, semester 2. So you will get a lot of foundation in immunology and biotechnology, cell biology, and the individual diseases in semester 1. And then in semester 2, we are sort of delving a little bit deeper into how do we use certain biochemistry assays to purify proteins, for example. How do we scale up these kind of things in semester 2? And we have some case studies. That's the disease, this is the treatment. How did we come up with this treatment? How did it end up in clinic? What do we need to look out for, and these kind of things. And then this all leads into the semester 3, which is the summer period. Next slide, please. Thanks. So here you have 2 choices. So you can either do a research project or this masterclass in biotherapeutics. So it's a 12-week sort of module. It's worth 30 credits. So you either do a literature review and then a project, and then you do an oral presentation. And the project itself can be done in a research lab in DCU, a research lab outside of DCU, or at your place of work. So if you're employed in the biopharma industry, for example, you can do your project also in your place of work, as long as it will take place alongside your peers on the program. So it has to take place between May and August. So this option, for example, is taken up by a lot of the part-time students that are working in industry, and then they're doing this MSc to upskill, for example, and they do the project in their place of work. And then the other option is the masterclass. So here you have very specific or a specific set of experiments that you will be doing. So there are these 6 masterclasses on the right-hand side there. So cell culture, and then protein purification and ELISA assay. And you also will write a grant. So this lab work will take place over 3 to 4 weeks. So it's much more condensed. You're in the lab, you're doing, pre-designed experiments. People will tell you this is what you're going to be doing, and then you have to do it. You need to, create your own results and analyze those results and discuss them. But you're not really designing your own experiments. You're not thinking academically about a certain issue, and you don't need to solve this issue. You're just going in, you're learning the techniques, and then you leave. And then in your own time, then you will write your literature review, and you will write a grant proposal. And then also there, you need to do an oral presentation. Okay, next slide, please. So that's just the overview here. All of these MSCs are assessed through continuous assessment. So rather than having one big exam at the end, you will have smaller exams all through the year, basically, or at least the 2 semesters. And you see an overview there of what we did in semester 1 this year. So some of those larger assessments are still coming up, but then you will have smaller MCQ-based assessments or little texts that you need to write or something like this throughout the year. Okay, next slide, please. Okay, next one. There we go. Yeah, you need to go to this website to apply, and you will find more information, obviously, about the program there as well. Next slide, please, which I think is also the last one. There we go. Course requirement. So the course itself is really, designed to be in between the other MSCs, really. It's highly tailored to folks who already have some sort of life science background. Like biology or even chemical science, some engineering. So we had a biophysicist on the program, for example. So these things are all fine as long as you think you will be able to handle the biology portion or the engineering portion of the program. It's obviously at MSc level, so some self-directed learning is obviously a prerequisite there. And then you can also be a healthcare professional. So we have some nurses applying, for example. We also have student education students applying. So recognition of prior learning, RPL, is also embedded in this program. So if you do not have a 2-1, for example, in some sort of life science degree, you can still apply. You need to write a cover letter and really explain why you want to do this program. And then I may invite you for an interview, or the program team will invite you for an interview. And we see how your prior learning, if you have worked in the industry, for example, really, helps you and brings you to the same level, let's say, as a graduate there. So you can do this program as well. And then obviously, you need to be able to speak English to do the program. And these are the fees. Again, we don't have scholarships. And if you have any specific questions, you need to address them to the fees office. But anyway, if you have any questions, please write them here or do get in touch afterwards. So the next slide, please. I think that's the last one. Well, career prospects. I don't know where our graduates have ended up yet. But this is just taken from the other MSc programs. And again, our graduates are very highly looked after and thought after in the industry. So there is a huge likelihood that you will get employment afterwards anyway. Then the last slide, I think it's just my face. There we go. That's me, my name and my email address. So please just get in touch, and that's it. Thank you very much.